Yo, what's up, guys? Yo, what's up? So, we're gonna discuss about halogenalkanes chemistry. Okay, so what is halogenalkanes? Halogens are carbon molecules that are attached to a halogen, so fluorine, bromine, chlorine, or iodine. I'm gonna make this like, for example, is fluorine. Make something that you would remember. The carbon's last electronegative, so the carbon will have a partial positive charge, have a partial negative charge in the carbon, and halogen can be attacked by a nucleophile. So what's this nucleophile? What is that? It's molecule that is electron rich. Many times you can identify this because they have a lone pair just like this. So when you look at the, for example, a hydroxide ion has a negative charge and is a nucleophile. Hydroxide ion. Why? Why is a nucleophile is negative? Because nucleo stands for nucleus, and a phile, it means love. So just remember that nucleophile is nucleus love. Nucleus made out of positive charge, so negative charge. Classification of alkyl halide. There are three main components which are primary, secondary, tertiary. The primary, halogen attached to a carbon with two hydrogens, so let's make up that. This is the halogen, and this is carbon. This is carbon. It only connects with two hydrogen. These are the primary, and then the other example is the secondary. So they connect to one hydrogen, so they connect to one hydrogen, and the other one is carbon and carbon, and it's just like the halogen. And the third one is a carbon that connects to no hydrogen. So all of the other components are carbon, halogen. And what's the difference between these? Why is it so important later? These are because the more carbon that connects with the alkyl halides, so the more stable it will become, because when it becomes a nucleophile, the other carbon stabilizes the middle carbon. Now let's start with the nucleophilic substitution. So you're gonna know the polarity of it. The carbon hydrogen bond is polar. So halogens are partially negative and carbon partially positive due to the electronegativity of halogenalkanes, because they are more negative than the carbon. So these are delta positive, delta negative. Yeah, so that partial positive charge on the carbon atom attracts species with a negative So electron rich, yeah, because halogen is more electron rich. These will be the products of the primary, secondary, and tertiary of SN1. So we're gonna talk about it later. This is S1 reaction. So this comes from substitution chlorophylllic 1 type 1 reaction. So what are these? These are like, there are two kinds of substitution nucleophilic reaction. These are one of them. And this reaction consists of two phases. The first one we're gonna talk about is this phase, and the second one is this phase. Heterolytic fission of bromine and carbon, and it becomes the bromine ion and a carbocation. And this is slow. Why? We're gonna talk about later. And then the second one is fast. Always. Because carbocation needs an electron so fast. So this OX. Donor it's electron to the carbon. So it's so fast. It becomes this here. Why is it slow and fast? Because due to the energy activation required, as you can see, it's higher than the second one. That's why it's fast and slow. And I forgot to mention this as one reaction. As you can see, this are the carbon is a tertiary alkyl halide because it is more stable. That means it's more harder for it to react from one another. So that's why it has two phases. But the acetyl reaction only have one phase, so it happens at the same time because this is a primary alkyl halide. Doesn't have it's not more stable, so that's why it's reactive. And this is a transitional state of the bromine, and just like the first reaction, but it happens at the same time. Yeah. Now let's look at the reaction of hydrolysis. There are three types of reaction in hydrolysis: reaction with water and aqueous alkali and aqueous silver nitrate. As you can see, these are the reactions. The aqueous alkali reaction contains halogenalkanes plus aqueous alkali. So the product is alcohol and salt. It's okay. Let's look at the aqueous silver nitrate. So aqueous silver nitrate is used to distinguish between different kind of organic chlorides, bromides, and iodides. Look at the tables. As you can see, when the reactive chloride is going to be white, when the reactive bromide is going to be pale cream, when reactive iodide is going to be pale yellow. Now let's take a look at ammonia. Ammonia molecule contains a lone pair of electrons, and the product of this is called ethylamine. Ethylamine possesses a lone pair of electrons in its nitrogen forms, and it's like anybody else. and cyanide ions are is one, the other one. And when a halogenalkane is heated under free flux with a solution of sodium, the product is called propanenitrile. The name shows that it contains 3 carbon atoms. The extra carbon is added to the original halogenalkanes chain. That's unique. The use of cyanide is a good method of increasing the length of a carbon chain by 1 atom, which can be useful for synthesis of organic compounds. So let's take a look at elimination reaction. Halogenalkanes also undergo elimination reaction in the presence of sodium or potassium hydroxide, which dissolve in ethanol. Notice that hydrogen atom has been removed from one end to the carbon atoms together with the bromine from the center one. In all simple elimination, things being removed are on adjacent carbon atoms, and a double bond is set up between those carbons, just like elimination. So let's take a look at the difference between these two. So the product will be double bond. Look at these double bond, the alcohol, and then in substitution, the halogenalkanes will be primary, bromoalkanes will be tertiary, and a weak base and a concentrated base, and a polar elimination is ethanol pure. The temperature is low and high. Just look at the difference. So propane C3H8 is used to reaction sequence below. So these are the reactions, and the question is reaction sequence shows several important reaction mechanisms. Select from reaction 1 to 4. That shows free radical substitution. So we're gonna only focus on the free radicals. Free radicals supposedly requires UV lights in order for it to right. So let's just search where UV lights are. So these are the UV lights, right? These are the UV lights. So the answer is reaction 1. The second one is electrophilic addition. Electrophilic addition. Let's just focus on the addition characteristic is double bond to single bond. Right? So we're just gonna search for the double bond, and so the double bonds are only this, right? So from double bond to single bond, it's reaction 4. So easy, okay, easy peasy. And the elimination characteristic is single bond to double bond. So these are the only double bonds, right? These are single bonds, all of the single bonds. You can focus on this single bond, change it to double bond. It's reaction 3. So the answer, reaction 3. So easy.
So for this question number 3, why are fluoroalkanes unreactive? The answer is D. The CF bond is very strong. And why the CF bond is very strong? It's because F is very electronegative. The bond won't easily break. So fluoroalkanes are unreactive. For the question number 15, which one of the following is not a suitable method for the preparation of ethanol? The answer is A, oxidation of ethane.
Now here we are with some example of questions. This question is about a method that can be used to prepare ethylamine. CH3, CH2, Br, yada yada. Which of the curly arrows in the mechanism is not correct? The answer is D. Because different from others, it has no purpose, it doesn't attack anything, it doesn't substitute anything, it doesn't try to break out from the compounds, and it isn't correct for breaking out of the compound. The next one is, which one of the following statements explains best why fluoroalkanes are the least reactive haloalkanes? The answer is also D. The CF bond is the strongest carbon-halogen bond. This is because of that fluorine is on top of the halogens in the periodic table, making it harder to bind with other molecules and does less attraction.